Generic list gives you a type-secure way to keep objects in collections, as well as being able to add items after you've created it. In this lesson, I'll show you how we programmed before generic lists, and how generic lists make your development life much easier. So in the beginning, there was array. And the array was good because it was type safe, which meant that it was an array of integers, or it was an array of strings, and everything pulled out of it was an integer or a string. But the problem with it is that you couldn't add any items to it once you created it. So if you created an array of 5 scores, and then you had a 6th score, you couldn't add that score to the 5 scores. You had to create a new array with the 5 scores plus the extra one of 6 items, so you would have an array of 6 items. And then you couldn't add to that. So it had a fixed number of items, which was bad. Then came along the array list. And the array list was good because it allowed a flexible number of items. After you created the 5 scores, you could add a 6th score and a 7th score and an 8th score, etc. But the problem was it was not type safe, which meant that if you had an array list with integers in it and you put a string in it, the code would still compile. But during runtime, when the program was taking all of the items out of the array list, thinking that they're integers, and it got to the string, it would throw an error. And so that was bad. Then along came generic list, which did them both. You can define a generic list with a certain type. T here stands for type. So you can define a generic list of integers, and you know that they're integers. They will always be integers. You can't put anything in it but integers. And you can add as many integers to it after you create it as you want. Let me show you how this works in a little more detail. Let's say we have an array of scores, which are integers. So we can define them here. Let's make a couple scores. Some good scores, some bad scores. Some more good scores. And we want to display them. So we have score and scores. And we can say display the score. So let's look at that. And we see the scores here. And that's just fine. And notice also that I can change the contents of it. So I can say scores 0. He didn't get an 89. He actually got a 82. And I'm doing Control C and Control V. And if I display them again, here, let's do a separator here. If I display them again after changing one of the scores, I see that here it was 89 and here it's 82, and that's fine. But let's say I try to add one. This is 0, 1, 2, 3, 4. I could change any of those, but I want to add one. 0, 1, 2, 3, 4. So I want to put 5 equals 99. And I run it. And it says that the index was outside the bounds of the array, meaning I cannot add to it once I create it. And that's bad. So along came the array list. And the array list, actually, because it's, as you can see, it's not used much anymore, so it's not even in the using system collections. There we go. The array list equals new array list can be defined in much the same way. So let me just take all of these and put them down here. So, oh, it's complaining about the score has already been used, so let's put that in its own scope and put our array list in its own scope, and that'll be fine. So I'm doing Control C, Control V. And now we have these scores, and with the same line here, Control C, Control V, we can display them. So let's go ahead and display them. I need to uncomment this so that we can get past it. So let's go ahead and display them, and you see that it displays them in the same way. Now, the great thing about the array list is that we can add to it. So if I say scores add, and I want to add another score, 99, I just do it. I go up here, Control C, Control V. Let's do this too, Control C, Control V. And now we see that this array list has 5 scores in it, and this array list has 6, which is great. But let's say somebody inputs an answer in a form for a score, but they don't type in an integer, they type in something like not applicable. And that gets saved to the array list, which is fine. It saves it, no problem. It compiles. And if we run it, it'll even show it. The array list doesn't care what kind of type goes into it. It'll take anything. And because we're outputting it in console write, it'll display anything. The problem comes if we're doing some kind of calculation on the number, expecting that it's an integer. For instance, let's copy this line here. So we have another separator. And then we say again for each score in scores. And then we say, let's write score was this, points missed was this. And so the first variable is score, and the second variable is 100 minus the score. And notice here's where the trouble starts, because although we assume that all of the items in this array list are integers, they're really objects. It says operator minus cannot be applied to operands of type integer, which is 100, and object, which is score. The array list doesn't even know that there are integers in here. It only stores objects, and that's the problem. And if we cast this object into an integer, which is fine, and it'll compile, and we took this out, it would even work. So we have the score was 89, and the points missed was 11, 91, missed 9, 99, missed 1. It all works. That's fine. But the problem is, if at any time at runtime something else gets in there, it still compiles, but it crashes because ArrayList is not type safe. What it tried to do here was cast the string NA into an integer and couldn't do it. So the program crashed. And that's bad. So in C# 2.0, finally we had generics, which allowed you to create generic lists. And it worked like this. So continuing in the same vein with the list of scores, we have list of type integer, which is key here, equals new list of type integer. And it gets defined in the same way, so we'll copy these over. Let me do that again. Control C, Control V. And now let's just copy the whole thing here, because this just works now. Since list will only accept an integer. And you see that here, that this will not even compile, because this is a string, and it is not allowed in scores, which is a generic list of type integer. And that's the magic of generic list, that you can add new items to the collection, and they, at compile time, have to be of a specific type. Therefore, it's flexible and safe. So in this lesson, you saw why developers like generic list so much. It gives us the best of both worlds: flexible collections and type-safe collections. And here is a simplified rule of thumb for choosing collections. If there's a fixed number of items, for instance, if you are storing the directions, north, south, east, west, and you know you're only going to have 4 and no more, then you can use an array. Otherwise, always use a generic list, unless, of course, there's some specific reason to use a more specific generic collection like generic stack or generic queue or generic dictionary. But in no case should you use ArrayList anymore.